Hello everyone. Today I'll show the solutions to problems 5 and 6 of round 172 of the Prairie Math League. For problem number 5, we're given the 9-sided regular polygon A1 to A9, and in this case I just labeled them A to I. And we're asked the number of distinct equilateral triangles in the plane that have at least two vertices in the set of points. So for instance, we could have this because it uses these 2 points. Or we could have something like this because it uses these 2 points. So when we see 2 points, 2 vertices, we're gonna think of like all the ways you can pick 2 points from these 9 points in total. So this already gives us like something to start with. 9 choose 2. So for instance, we could choose these 2 points and we get this equilateral triangle. However, we could also get the inside equilateral triangle. So we also have to multiply by 2. This already gets us very close to the answer. However, there are quite a few overcounts. So for starters, let's say that we chose this point and this point. Then if we draw this inside equilateral triangle, we count this equilateral triangle here. But if we choose this point and this point, we get, and go inside again, we get the same equilateral triangle, and the same thing happens if we go this point and this point. So the thing is, we've counted this equilateral triangle 3 times, which means we've overcounted it twice. And there are three such equilateral triangles. One is here, but there's also this one here and this one here. Each equilateral triangle was counted 3 times, meaning we've overcounted it twice. Therefore, to get the correct count, we have to subtract 2 times 3, number of overcounts times number of triangles that were overcounted. And this gets us 72 minus 6, which is equal to 66. And this is option choice D. Okay, for problem number 6, we have 3 people, Jason, Kevin, and Ethan, and each can walk at 6 kilometers per hour, but they also have a motorcycle which can go at 90 kilometers per hour. But this can only hold at most 2 of them at once. Let t be the time taken for all 3 of them to reach a point 135 kilometers away. So this distance is 135 kilometers. Ignoring the time required to start, stop, or change directions, what is true about the smallest possible value of t? So first of all, to solve this problem, it should be noted that we should find, in fact, the way to get the smallest possible value of t. In other words, we wish to find a way for these 3 people to get to the other side in the shortest amount of time. Now, one way to do this is by going to the end, just taking 2 people, going all the way to the end, going back, and then taking this, okay, so let me say it this way. Suppose Jason and Kevin go all the way there, leaving Ethan behind. They're all dropped off here, and once they go back, Jason picks up Ethan while Kevin is already at the other side. And then they just go back. Unfortunately, this is not a very time-efficient method. So what we can do is we can make them walk instead. So suppose they start, Jason and Kevin start on a motorcycle. But Ethan doesn't need to just stand there and waste his friend's gas. He can actually start walking while they keep on moving. And so in a similar fashion, once Jason stops to drop off Kevin, Kevin just needs to be dropped off here. He can actually just walk all the way for the rest of the journey and meet with a motorcycle as it comes back. So in this case, Jason and Kevin go to the right while Ethan walks. Jason drops off Kevin, and it goes to pick up Ethan. And then finally, they meet, and they go back and meet and they all reunite at time t. Now, this is a nice way to plan an abstract diagram, but in reality, we're going to need to make this problem more abstract so that we can actually do some algebra. So we can plot the motorcycle's path as something going like this. So the motorcycle goes this distance, let's say until this distance d, and then drops Kevin off while it goes back, and then some other distance, and then goes back here. But notice that this is basically symmetric, because they're basically walking exactly the same distance in the same amount of time. And this can be just noted by symmetry. Therefore, this distance is also d. And now we can solve for the amount of time time taken, or specifically like for d. So the way we're going to do this is by taking this total time. So Jason is going to be the one who's going to be on the motorcycle all the way. And we can also note, say, Eason's perspective. Eason walked this distance and then picked up and then went all the way here. So Jason first went this distance. This is 135 kilometers minus d. Then went this distance, which is 135 minus 2d. And then finally went 135 minus d. So the total distance is 405 minus 4d. And we're going to note that the amount of time that Jason spent is equal to the amount of time that Eason spent. This is just obvious. So Jason was on a motorcycle all the way, so we divide by 90 kilometers per hour. And this is equal to Eason's perspective. So Eason walked at 6 kilometers per hour for distance d. And then the last 135 minus d kilometers was traveled by motorcycle. And we can do this to solve for d. D is equal to 15 kilometers. And once we know this, we can plug this back in, for instance, setting it into Eason's perspective, and show that the time is about 3.83 hours. And this is option choice A. And one thing we can note is that we don't even know if this might not be the fastest way, but we don't really care anymore because this is option choice A, which already allows us to eliminate all the other option choices. And we're done. Thank you for watching.